Why are intensive properties independent of mass? Imagine you're holding a small cup of water and a large bucket of water. No matter how much water you have, some qualities stay the same. That's what makes certain properties special. Today, we're talking about why these qualities, called intensive properties, don't change when you add or remove mass from a system. Think of properties like temperature, pressure, and density. These are called intensive because they describe the material itself, not how much of it you have. For example, if you have a glass of water at 100 degrees Celsius and you pour that water into a larger container, the temperature stays the same. The same goes for pressure and density. They stay constant even if the amount of water changes. Now, contrast this with extensive properties like mass or volume. If you cut a piece of metal in half, its mass and volume are cut in half too. These properties depend directly on how much material you have. But with intensive properties, it's different. They are ratios or qualities that don't depend on the total amount. Take density, for example. Density is the mass of a substance divided by its volume. If you double the amount of water, both the mass and volume double. But because they grow at the same rate, the ratio stays the same. So, the density remains unchanged. That's why density is an intensive property. Temperature measures how fast particles are moving inside a substance. It doesn't matter if you have a tiny drop of water or a big lake. The temperature can be the same because it reflects the average energy of particles, not how many particles there are. Pressure is force per unit area. Whether you're measuring the pressure inside a small bottle or a large tank, the pressure can be the same if the conditions are the same. It doesn't depend on the total amount of fluid but on how force is distributed over an area. Another reason intensive properties are independent of mass is that they can be measured at a single point. You don't need the whole system to know the temperature or pressure at one spot. This makes them very useful for describing local conditions. In thermodynamics, understanding these properties helps us compare different systems easily. It allows us to predict how systems behave during processes without worrying about their size. For example, the boiling point of water stays at 100 degrees Celsius at 1 atmosphere pressure, no matter if you have a cup or a swimming pool of water. The same goes for the density of pure water, which is about 1 gram per milliliter whether you measure a tiny drop or a large container. And the temperature inside a room is roughly the same at different spots, assuming the room is evenly heated. So, to sum it up, intensive properties are independent of mass because they describe qualities or ratios that stay the same no matter how much material you have. They help us understand and compare systems in a simple, straightforward way.